Okay, so the problem reads, a certain drug treatment cures 90% of cases of hookworm in children. Suppose that 20 children suffering from hookworm are to be treated, and the children can be regarded as a random sample from the population. Find the probability that all 20 will be cured, all but one, exactly 18, and so we'll start off with A here, okay? So in this is a binomial problem. We know that because it's in the binomial section, but we also know it just because we can treat each of these children as kind of independent, quote, not random experiments, but it's like selecting a child at random. Does this child have, all right, will the hookworm treatment work, okay? And so in our case, we need to identify N, P, and J. All right, so N for all of these problems is going to be 20, and P for all of the problems is 0.9. And it's just that in between A, B, C, and D, J will be changing. So for part A, all 20 will be cured, J will be 20. So keep in mind that 0.9 represents the probability of being cured, right? Okay, and so in this case, we're going to just use the binomial formula, which is n choose j, p raised to the j times 1 minus p raised to the n minus j, okay? And what this means is we want p successes, the probability of we want j successes. The probability of a success is p, and it has to happen j times. Probability of failure is 1 minus p, and it has to happen n minus j times. So in our case, we've got 20 choose 20, 0.9 raised to the 20, 1 minus 0.9, I'm just going to just write 0.1 raised to the 0. And this one is actually easy because 20 choose 20 reduces to 1, and anything raised to the 0 power reduces to 1. So we really just have 0.9 raised to the 20th. So here I'm going to punch that in, 0.9 raised to the 20th, and I get 0.12157. So our answer for part A is about 12%, a little bit more than that, 0.1216 if I round off. Okay. In part B, we've got the same setup. All but one will be cured. All but one will be cured means our n is 20 and our p is still 0.9, but our j, all but one, means 19 were cured. Okay? So in this case, we're going to have 20 choose 19. The probability of a cure is 0.9 for each one, and that has to happen 19 times. And the probability that someone does not get cured is 0.1, and that has to happen 1 time. Okay? So I'm just going to punch this straight into the calculator, which is going to be 20 choose 19 times 0.9 raised to the 19 times 0.1 raised to the 1, or 0.1 raised to the 1 is just 1. So in the calculator, I'm going to do 20, and I have the choose button. Your calculator might be different. I got 20 choose 19 times 0.9 raised to the 19 times 0.1, and I can raise it to the 1, but it's not necessary. I'm just going to hit equals, and I get 0.2702. So my answer here, 0.2702. All right, and I hope that's so far so good.
I have a question. How do you
Yeah, let me. Okay, with part C, it says exactly 18 will be cured. So in this case, we've got n is equal to 20, p is equal to 0.9, and j is equal to 18. All right, and so here, just plugging into our formula, 20 choose 18, p, probability of a success, 0.9, that has to happen 18 times. The probability of a failure, which is 0.1, has to happen 2 times. So I'm just going to punch this in, and in fact I can just edit my last entry if you've got one of these calculators. So 20 choose 18, 0.9 raised to the 18 times 0.1, and now I have to square this one, okay? 0.1 squared. Enter. and I get 0.2852. So my answer there is 0.2852. Okay. And lastly, part D says exactly 90% will be cured. Okay. So here we're still going to have n equal to 20, p equal to 0.9, and j has to be a whole number. We can't say 90%. So what we've got to do is we've got to convert 90% into a number. So we have 20 children, so 20 times 0.9, 90% of 20 is 18. So D is basically asking the exact same thing that part C was, except it's just being different, right? Just in a different form. So exactly 90% of the 20, this is the same thing as saying exactly 18 are cured.
The word exactly on the plane in the column at all?
Give me a second here. Okay, and then so for D, our answer is going to be 0.2852. So that's our answer. We don't have to do any recalculations. Okay. Yes, and so this this word exactly is important, because had number C said something like, so if there was a part E that said at least 18 are cured, okay, which is different. At least 18 are cured. This is actually going to be multiple problems. This is n equal to 20, p equal to 0.9, and j equal to 18, 19, and 20, because that's what at least 18 are cured. So the answer to part E, if there were one, would be the sum of, because with j equal to 18, we know that's 0.2852. With j equal to 19, we've done the calculation. That's 0.2702. And with j equal to 20, the answer is 0.1216. So if there was a question that says at least 18 are cured, then our answer would be the sum of all of these things. And our answer would be 0.677. Okay. All right. I hope that answers that question.